So our project is on Route Me Too, providing spatial and contextual awareness for assisted transit systems.
Hi, my name is Terry Huang, and I'm a rising sophomore at West Campus High School in Sacramento, California.
My name's Asher Kornfeld, and I'm a rising senior from New York City.
And I'm Toby Aswell. I'm a rising senior going to Pioneer High School, and I'm from San Jose, California. And our mentor is Fatima Mirzai. So our problem, navigating a public transit can seem daunting for many. And this is true, especially for people with blindness or impaired with cognitive disabilities. Notice the blue dots at the top left. Here we have a pedestrian route to a bus stop taken via Google Maps. We have another route that goes to the transit center. Consider someone with blindness or cognitive disabilities. There's no way to guide the users to get to the transit system. This is due to the lack of detail in routing in multi-slot transit centers. Google Maps doesn't guide the user to the transit system as the route ends at the edge of the multi-slot platform. Such details that are not available is which stop is it, where the stop is located, if there are any crosswalks around, or if the user is even located in the right corner or direction. Modern GPS technologies such as Google Maps and Apple Maps are not equipped with handling pedestrian navigation, as they have very limited GPS accuracy for pedestrians. Our solution is a navigation app called Route Me To that can be used on iPhones. These provide more detailed directions than conventional apps via our voice command control. This is tailored to users with visual or cognitive impairments as they are purely audio, and it provides more accessibility as they can be used on any smartphone or device.
As Toby said, we provide more detailed information than traditional apps like Google Maps, and we do this by generating a local route when users enter a complex transit station. We call this the microroute, and it uses a series of tiles to create a path that users can walk across. This can be seen on the right here. The green line is the microroute we're talking about, and the tiles are the ones highlighted in red. The route constantly updates based on your location so that you can be rerouted if you accidentally veer off track. As it said in the title, we also provide spatial and contextual awareness to users, and we do this by using landmarks and points of interest to help communicate surrounding objects. All of this is conveyed via voiceover in the app. One main component of our app is tiles, which I talked about slightly earlier. And these are basically areas that RouteMe2 uses to help guide users to their destination. They're basically polygons over an area, as you can see on the right here. And they're generally 5 to 10 meters in length and connected to form a path that users can walk across. As you see on this picture on the right, users can walk to their destination by going across a series of tiles. Two other main components of our app are landmarks and points of interest. Landmarks are basically large areas around tiles like railroad tracks, streets, restaurants, and shops that users may find interesting, and points of interest, which are objects in or near tiles like traffic lights, trees, and benches, shelters that users may want to take advantage of or avoid, like trees. Here is an example of the tiles we would use at an intersection. The streets here are examples of landmarks that users would want to know about and to avoid. Here are examples of points of interest. Under the tree here, there's actually a bench, and users can take advantage of that if they would like to. And a tree is also an example of a point of interest as shown here. tactile pave. Users may want to know about tactile paving because it can help them know when a crosswalk starts, as well as traffic lights that can let them know when to walk across the street. Here is a picture of all of the features. So recap, why do we need this information? Apps like Google Maps and Apple Maps don't provide enough information to users. So we're trying to help with that by giving more information. Apps like Google Maps and Apple Maps can help you get to a transit station and direct you to take a certain bus or train, but they can't really guide you inside the transit station to where you need to be in order to catch the correct ride. RouteMe2 solves this problem by taking over control after reaching a station and using a locally generated route to help users get to the right location where they can stand and just take the bus when the bus arrives.
So in order to create these tiles, points of interest, and landmarks that Terry was talking about, we used a software called Mapbox and created each individual set of tiles at a bus stop near each of us. And as you can see here on the picture, there's an example of what Mapbox might look like. You can see all the tiles are outlined in blue, and the points of interest, like one of them is the traffic light, and we define these points. And you might say that this doesn't seem scalable, and you would be correct. So we currently are working on ways to try and automate the tile generation, since we had to do it manually for each of our bus stops. And so that is part of our future work. And next, you can see this is just a simple demonstration of our app. And it's going to show a user traversing these tiles. And as you can see, the tiles, they turn green when the user is in them and gray out once the user has passed them. And also it creates a route from the user to the bus stop that they want to go to. And that's a bit off screen near the top, but the cursor is pointing to it right now. And if you can see, the green line on the map is also the route that the user should take, but it's the route that Google Maps might give you. It's the route that says, go to the bus stop and then go here. And so, yeah, this is just a demonstration of our app. And on the next slide, our future work. We are currently working on a new and revamped user interface design, which you can see an example of on the right. This will include the voiceover compatibility that we've been talking about, in addition to a lot more information that it can give you, such as a brief route description that gives you ETA, a more detailed route description that can give you all sorts of directions like Google Maps would give you, but way more detailed. In addition, you can ask it questions such as, where am I and what's around me, which will again draw on the data from these tiles and points of interest in order to answer your question. And as I was talking about with the voiceover, one of our main goals is to implement this, and for people with blindness, have the app speak to them instead of having to press these buttons and read it out manually. And in addition, the tiles and directions, as I said, were both manually generated. And so we're working on ways to automate this, either using an algorithm or some other way. So in conclusion, we've all been working on this project for around 2 months now. And in the beginning, none of us knew anything about this. We didn't know any Swift, which is what this app was coded in. And yet at the end of it, we've all made significant contributions to the app. In addition, we learned how to define these tiles and points of interest using Mapbox just to get a sense of what it would be like. And we did it manually. And also, as this is a research project, we started this with researching these concepts like Terry and Toby were talking about with micronavigation and micro-routing and how that applies to public transportation in the real world. And we really learned how to gather information on these scientific concepts and aggregate them either in a presentation, paper, or just gather information in order to create new ideas for what we want to have in our app. And that's it. Thank you. And any questions you might have, feel free to ask them or put them in the chat and we'll try to answer them. So Catherine asks, what are your ideas for scaling the tile creation system? As I said, currently we're doing it manually, which isn't really scalable, but we are just exploring generating them with different algorithms, and it's still in its very early stages. So it's not much of a fully fleshed out idea. It's just something we want to do in the future. Also, I think I think one thing we forgot to mention was that GPS is inherently inaccurate. And so when we're working on this scale, in some areas, like in the app demo, it was pretty accurate, but in some areas it can be inaccurate to the degree of 5 meters or even 10 meters, which is a lot if you're working in a single bus stop. And so we're working with the inertial sensors on your iPhone, which is basically like your accelerometer, and using that to further fine tune the position, and in cases where the GPS is completely inaccurate, using solely that.
That looks like that's it. I don't see any more questions. If there are, though, feel free to put them in the chat. And yeah, thank you guys for presenting. Great job on your presentation.
Thank you.
Thank you.
Yeah, and I think that brings our first session to a close. Let me just double check, make sure. Yep. So from 10:45, we ended a little bit early, but at 10:45 to 11, that's going to be a break before the second session begins. Good job on everyone's presentations. They're all very interesting to listen to. And yeah, feel free to take a Zoom break